Okay, welcome back to part two for 3.2 in pre-cal, solving more complicated exponential equations. A minute ago, we did the video for the quadratic forms. Now we're going to do some that are just a little more fun than that, like you saw in your pretest. Equations in this form, where you have something raised to a power plus something raised to negative power over that something minus something, and it's equal to some number. And so you saw several of those in your pretest. And now we're not going to have enough to find the exact solution algebraically yet, but we will be able to reduce it to an equation such as these that might be true, that has to be true. So let's take a look and let's solve one. An example like this, we're going to use some properties of fractions that say when you multiply a fraction by its denominator, you cancel the denominators. So if we multiply both sides of this equation by the denominator of the fraction on the left, 3 to the x minus 3 to the negative x, then on the left side, that cancels and leaves me with 3 to the x plus 3 to the negative x equals, and I distribute this 10 and get 10 times 3 to the x minus 10 times 3 to the negative x. Now understand, properties of exponents, you cannot combine these two and multiply that and say it's negative 30. You cannot do that. That's not equivalent to that. This is 10 times 3 to the negative x. This is 10 times 3 to the x. It's not 30 to the x power. You cannot combine those unless they have the same exponent. If you had 10 to the x times 3 to the x, then you could say that's the same thing as 10 times 3 to the x power, or 30 to the x. But that does not equal 10 times 3 to the x power. So let's make sure we're clear on that right off the bat. So what we have here are terms that we can combine like terms. Our 10 to the x term are like terms, and our 3 to the x terms are like terms, and our 3 to the negative x terms are like terms. So we're going to subtract 3 to the x from both sides, and we're going to add 10 times 3 to the negative x to both sides. Oops. These cancel. This leaves me 11 times 3 to the negative x, 1 3 to the negative x, plus 10 times 3 to the negative x. That was supposed to be equals. Oh, no, that was minus. There it is. So then I have my 10 times 3 to the x minus 3 to the x leaves me 7 times 3 to the x. And these cancel also. And so now what I can do is use a property of exponent. Recall that if we have don't you hate it when you lose your pen? If we have a to the x times a to the y, that equals a to the x plus y. We add exponents. If we have a to the x times a to the negative x, and we add exponents, we end up with a to the x plus negative x, or a to the x minus x, which equals a to the 0 to 0, which is just 1. And so we're going to use that, and we're going to multiply both sides of this equation by 3 to the x. So that when I multiply 3 to the x by 3 to the negative x on the left, I get 3 to the 0, which is just 11 times 1. This cancels this because we add the exponents, get 3 to the x minus x, 3 to 0, which is 1, so we still have 11. Here we still have the 7, but we have 3 to the x times 3 to the x. We add the exponents and get 3 to the 2x. And when we divide that by 7, we get 11 sevenths equals 3 to the 2x. And that's the form of the solutions that you're going to see for your exit ticket and your homework today. Later next week, we will learn how to solve those algebraically using logarithms. But for now, that's where we're going to get to, is those equations. Let's do another example like that, and we'll call it good. Here we have another equation with e. E is the base of the natural logarithm. We will see that a lot as we move through this course. So we're going to do the same thing here. We're going to take this and we're going to multiply numerator and denominator or sorry, not numerator, both sides of the equation by the denominator, e to the x plus e to the negative x. When I multiply on the left side, it cancels the denominator, it gives me e to the x minus e to the negative x. And when I multiply on the right side, it gives me 1/10 e to the x plus 1/10 e to the negative x. So once again, I'm going to combine like terms. I'm going to subtract 1/10, e to the x from both sides. And I'm going to add e to the negative x to both sides. Remember that 1 e to the x is also 10 over 10 times e to the x. So when I subtract the 1/10, when I subtract the 1/10 e to the x, I end up with 9/10 times e to the x. These cancel. These cancel. And here, 1 times e to the negative x is 10 over 10 times e to the negative x. So when I add those, I end up with 11/10 e to the negative x. And the next thing I'm going to do is multiply both sides of the equation by e to the negative, or sorry, e to the x. So that when I multiply on the left side, I get 9/10 e to the x times e to the x is going to be e to the 2x. And that's going to equal 11/10 times e to the x, or negative x plus x makes e to the 0, or just 1. So I end up with e to the 2x. Now I've got tenths on both sides of my equation. If I multiply both sides by 10, that's going to cancel the denominator here, cancel the denominator here, and I'll just end up with the equation 9 times e to the 2x equals 11/9. Oops, sorry, equals 11. I was trying to do 2 steps at once there, getting ahead of myself. So I divide both sides by 9, and I get e to the 2x equals 11/9. And again, what you'll see is that will be your solution to the equation, the equation you'll solve once we learn algebraically. For now, we'll go ahead and do that graphically. We will do again. We'll take the calculator and we'll type in y equals e to the 2x. Second ln gives you e to the power. Then we'll put 2x in that power, close parentheses, and put that equals, 11/9 is going to go in the next one. And then we'll graph. There's e to the 2x. There's 11/9. And we want to do second trace, intersect, first curve, second curve, tell it to guess. And the solution is 0.103335535. Let's see, let's write that down. 0.1033, let's see. Well, 0.10 is going to be pretty close. What I want to show you here is if we plug that in to this, we will get the same thing. So we're going to second quit, we'll get about 1/10. So I'm going to do second e to the x. I need to put that in parentheses, so let's go back. I need to put the numerator in parentheses on this calculator. E to the x minus e to the negative x. Close parentheses on the numerator, divided by, open parentheses on the denominator, e to the x. I didn't mean to do that. I meant to put 0.1 in there, doggone it. Minus e to the 0.1, negative 0.1. then close parentheses, divided by now e to the 0.1 plus e to the negative 0.1 and that should be really, really close to 1/10 or 0.10. And it is really, really close to 0.10. That would round up to 0.10. And so that's an approximation for the answer. And that's how we solve these kind of equations.